Good afternoon, ladies and gentlemen. My name is Naimi-Jamal. I come from Iran and want to explain our results about nanometal organic frameworks, especially copper-based one as efficient catalyst for chemical transformations. Okay, let me go back to the times that I was in Germany in the work group of Professor Kalb, and we were interested in doing chemical transformations in an environmentally friendly manner. I'd like to explain 2 of 12 principles of green chemistry. The first one is prevention, that explains that it's better to prevent waste than to treat or clean up waste after its production. And the 5th one is explain that it's better to use safer solvents and auxiliaries when possible in the chemical transformations. And the 2 are in the direction of green chemistry. As you may see here, you see that prevention and reduction is the most important aspect of green chemistry. And the last one is disposal. That means that after producing waste, we should dispose of it, and it's the worst one in this sequence. But the problem was which solvent is the best solvent, which is the greenest solvent at all. Today, the chemists use ionic liquids, immobilized solvents, or supercritical ones as listed here. And perhaps we may think that the water will be the most greenest one among this list, but I think it's good to mention that if we can use no solvent, it's the best way to prevent producing a waste in the chemical reactions. We were interested actually in doing the reactions, chemical reactions, without any solvent, but the problem is how we can make a reaction without any solvent. These are the methods that we have used. For example, this mortar, pestle and mortar, and oven, for example, or some grinder like this one is a vibrational ball mill or an industrial ball mill. We have used a vibration ball mill apparatus like this. This is a vibrating system. It means that you will put the gradients, the reagents in this vessel, and the system will vibrate in this manner. The gradients will be put there with 2 balls or 1 ball of stainless steel or tungsten carbide or, for example, Teflon balls, and the system will be vibrated, and the powder will be grinded, and the reaction will proceed. Okay. This is an example that we have used in this work. We have used a mixture of copper acetate, benzene dicarboxylic acid, and a diamine in a molar ratio of 2 and 1. They have been poured in a 10 milliliter ball mill vessel and grinded vigorously at 28 Hertz, and no solvent have been used in this reaction. The temperature was room temperature, and the reaction time was 2 hours. You can see the scheme of the reaction here. This is the diacid or copper acetate and diamine, and such structure have been produced during this reaction. As you may be familiar with such reactions, with such substances, they are called metal organic frameworks. In such substances, the copper or the metal the metals are connected with the diacid and the diamine between the planes. This is a plane, and this is another plane, and these are connected with diamine. The usefulness of such a structure depends on the pore size of the material. For example, here you can see the pore in between the structures here, and this pore will be used in, for example, absorption of pollutants from water, for example, or it's a place suitable for performing chemical transformations. In addition, perhaps it's good to mention that, for example, copper in chemistry in Lewis acid. It means that many reactions can be catalyzed by copper itself. And when the reagents come inside into the pore, and there will be enough near to the copper center, and the chemical reactions will be catalyzed more efficiently than other cases. You will see also here, this is the vessel, this is the ball mill vessel, and these are the two balls, and the pulver is the product of such reaction without any solvent. We have prepared the pulver and analyzed with different methods, such as, for example, elemental analysis or IR or something like this, that I have thought that it's not interested for this audience, but perhaps the BET, you can see that the type of the porous material is a type 4, and it is a microporous material with a size that I have explained later. This is also the XRD pattern of the mechanochemically prepared MOF or metal organic framework Cu2BDC2 DABCO. You can compare here the XRD of the as prepared sample with the XRD calculated from the single crystal structure with the programs. They are in good agreement with each other, and it says that the prepared pulver is really crystalline. It's very important. We have also measured the surface area of the pulver, and as you see here, our pulver has a surface area of 1,500 nearly, while the sample prepared in the sonochemical method, it's about 500 per gram. As you may be perhaps familiar with such substances, they are prepared normally in solvents such as DMF. DMF has a boiling point, has a very high boiling point, and it's very difficult to take out the solvent from the structure that it is prepared. Therefore, mechanochemical is better because you have not used any solvent in this method. This is also the TM of the prepared pulver, and you see that the porous structure of the substance. Okay, I like to present two examples of the chemical transformations here which have been catalyzed by this CuMOF that we have prepared by solventless system. It is, for example, a reaction between benzene and aldehyde and ammonium acetate, and this reaction will produce imidazoles system that, for example, in this case, it is a 3-substituted imidazoles. You see that the reaction needs just up to 6 minutes reaction time, and the yield of the reaction is up to 96%, which is very high. This is also a general procedure of the system. MOF was added to a flask containing a mixture of the reagents, and the mixture was irradiated by microwave. The reaction will also be proceeded without microwave, but in the presence of microwave irradiation, the time of the reaction is less and the reaction is very faster. This is also another reaction that we have studied with this MOF. As you may see, this reaction is to prepare carbamates. The reaction is here also very efficient, up to 99% yield will be produced. which in 30 to 90 minutes reaction time that is advised. Here we have also, for example, for this reaction, we have also studied different oxidants that I think it's not very interested for you. But here, for example, in this slide, we have compared the effectiveness of this catalyst with the previously described ones in literature. For example, here CuCl, 80 degrees centigrade, 15 minutes, 96%. But this is our system that you see that it's very efficient, up to 99% we can. The conclusion is I wanted to explain here a general concept. General concept is that we can produce nanostructure materials, especially nanoporous materials, in a solventless method. This is, I think, this is a very interesting, perhaps, aspect of this work, and it's advisable to test a reaction at first without any solvent, and if you have concluded that, for example, a solvent is necessary, then we can use. But it's better to not use any solvent at first. Thank you very much.